This is the merge sort. We're going to start by separating the array in half. We will continue by separating each smaller array in half until each element is in an array by itself. We will now combine the elements into larger arrays. We will look at the first element in each of the small arrays and place the lower value in the next slot in the larger array, and repeat that until all of the elements have been combined into larger arrays. We will now do this again with the arrays of size 2 until we are left with arrays of size 4 and size 3. We will now do this again with the array of size 4 and 3 to combine them into one array. We look at the first element in each of the arrays. Here we are comparing 3 and 5. 3 comes before 5, so that goes next. We compare 4 and 5. 4 is less than 5, so that is the next element. Here we compare 5 and 6, and now 6 and 7. This whole process is done by calling a method recursively so that the process can be repeated until all of the elements have been combined in an array. We will now display the merge sort method. We begin by selecting a pivot value in the middle of the array, in this case 3. We aim to have all values to the left of the 3 be less than or equal to 3, and all values to the right be greater than or equal to. Because 7 is greater than 3, we switch them. The indices which count from either side of the array intersect at 2. We now split the array at the point at which the 3 originally was. We select a new pivot value. In this case, it is 3 again. Because 2 is less than 3, we will switch it with the 3. We will do the same with the array of 4. We select 4 as our pivot value. Because 7 is greater than 4, we will swap them. The indices now intersect on the 5. We will split each of these arrays into a smaller one now. We select 1 as a pivot value for this array. It is the only element, so there is nothing to switch it with. We select 3 as the pivot value for this array. 3 is greater than 2, so there is nothing to switch. We repeat the process with the array of 5 and 4. 5 is greater than 4, so there is nothing to switch. Here, with 6 as our pivot value, 6 is less than 7, so 6 and 7 will be swapped. Now all of the arrays will be recombined in order. The quicksort method has worked because it uses a recursive method in order to sort part of each array and then break it down smaller and smaller until the entire array has been sorted.